Hi everyone, and welcome to this edition of the Humans of AI. My name is Paul Stephen Cunningham. I am one of the directors of the Data Science and AI Association of Australia. And in this edition, I was lucky enough to interview Sunil Mallya. So Sunil is the principal deep learning scientist for applied machine learning at Amazon Web Services. Sunil has had a very interesting and colored career journey around machine learning, both in academia, as an entrepreneur, and now working at Amazon. He is one of the leaders for the AWS Deepracer program and the Sagemaker RL platform. So this is the very first international edition of the Humans of AI. And at the time, I was using AirPods on my side to record it, and the quality did not come out so good. But surprisingly, Sunil's audio quality came out really good. So with that being said, I'm really excited about this particular episode. Lots and lots of really, really useful information. So let's get to it. Welcome to the Humans of AI. I thank you so much for doing this.
Thanks, Paul. Super excited to be here and joining from San Francisco.
Yeah, the time difference between Sydney and San Francisco is very interesting.
I'm glad you've made this early.
Okay. Yeah. So just introducing Sunil Mallya. Sunil is the principal deep learning scientist at Amazon Web Services Deep Learning Lab. So it was really fantastic to meet you at AWS Deepracer at Summit this year. A real honor, and again, thank you for doing this. Yeah.
No, I'm excited to be here. It was a super fun interaction that we had. I'm glad we've connected since then.
Cool. So yeah, just this podcast is called The Humans of AI, and essentially, I'd love to hear more about you and how you got started in machine learning. So first up, the question I always ask everyone is, how did you get started in tech? What was the initial draw to like computers in general?
Yeah. I mean, that was it's a sort of a hard question, I would say. And I want to go as far as I can remember. And I want to say it was mostly the movies. That's what I would blame. Growing up as a kid in early 90s, I think just, that's when computers were taking over. Internet wasn't quite a thing then yet. But I think it was just watching a lot of movies where people were doing really cool things, and the possibility that you could bring about by using a computer. I think that's what drove me into tech and computers.
Okay. Is there any movies in particular, like Independence Day or anything that comes to mind?
Oh, Independence Day was much later. I want to say Terminator. That makes me sound bad, but
oh, no.
it was well, the tech part was the exciting part.
Yeah, sure. Terminator is a classic. It's a classic.
Yeah.
Awesome. And then, okay, so obviously moving from your inspiration from movies, then how did you go from that to essentially getting started in machine learning?
Yeah, the machine learning part was it was sort of accidental, I would say. So I would say distributed systems was my first love, and working with my advisor in grad school. But I was always interested in new problems, and one of the problems that I started taking on was which happened to be my master's thesis, was energy tracking in a house, and
Right.
to sort of identify devices in the house in a non-intrusive manner. Machine learning was the solution. Like how would you do? How would you identify? How would you build a model? How would you disaggregate the power consumption? So sort of machine learning was a tool, and I was I would say I was fairly familiar at a high level, and this is again talking about classical machine learning back then. So that's sort of how I
So can
got
I say, like,
started.
back then being roughly what year range are we talking here?
Late 2000s. So I got into search engines, which was very an exciting topic for me. But again, hadn't built anything then yet on with respect to search engines.
Mm-hmm.
But this was like the real hands-on. Let's get into the theory, learn about SVMs back then, logistic regression, all of those, getting deeper into those, and then actually applying it. But to be honest, majority of the time was spent on the feature engineering side and less on the machine learning side. Now that I look, reflect on it.
But yeah, I think it's a classic like data science experience when you're all excited about the algorithms and you jump in there. And it's just a lot of data engineering and piping it around. It's very interesting that you mentioned that because I've done a lot of work in energy metering as well for strata buildings. What frequency? This is purely out of curiosity. What frequency of data were you dealing with?
Oh man, you're dating me now. So
Is
essentially,
this
I was
also
looking
like
at two.
is it pre Andrew Ng's course as well? Like
Oh yeah. There was another course.
no MOOCs, nothing.
That was no. You had to read the classic Bishop book and yeah, working on that. I forget the spectrum, but essentially you're looking at two different spectrum. But anyways, because we were always dealing on the frequency side in the sense. We got, there was an ADC that would convert the signal, and once the signal is converted, run a bunch of FFTs and work, past that. So I don't quite remember the spectrum per se, but was looking at two interesting. So as you switch on a light, you get so the light switch itself has a signature that emits a very spiky signal. So it's a very short-lived signal. So there was one signature that you would extract. The other one was called continuous signal. So there's sort of a noise injection that every device actually emits in your house circuit. So you would pick up on the continuous signal to actually understand what device was on. But the fun part is it's not just one device; it's multiple devices, and they all you can superpose with each other, and depending upon their phases, the superposition can be you can either decompose them or they can just blend into each other. So that was the most difficult part.
That's the hard part. It's the fun part, really.
Fun part, right? Like superposition of waves and decomposing that.
Yeah, cool. Fantastic. Okay, so that's the work you did for your masters. The next thing is we just mentioned that right at the start. So I'm in Sydney, you're in San Francisco. This is out of personal motivation, and I guess for everyone listening, because there's a lot of people thinking the same thing, is like, what is the machine learning community like in San Francisco? And I ask this from more like a community sort of side of things. So are there meetups? Are there like salons? If you know if you're familiar with salons, what's the in a nutshell, what's the ML community like over there?
Yeah, I would say tons of meetups. Tons of meetups do happen here. In general, with tech scene, I would say, which is why I still love this city, and I keep giving examples where you sort of pick up a framework and you're struggling as a developer to get something to work, or you've picked up on something very nuanced, and then you're at a meetup and you're trying to discuss, or the topic comes, and then the person who's the author or the maintainer just happens to be there. That's how I describe San Francisco in a nutshell. So tons of that culture of people really pushing the edge. And as far as machine learning is concerned, I think we do have a critical mass of people given the companies that are innovating in the Bay Area, San Francisco Bay Area in general. So tons of these meetups, always fun. I think also people are very open to have a conversation and intellectually driven. A lot of times you can't talk about what you're working on, of course, but I think people really keep up with the latest research, are willing to share, collaborate.
That's going to be a question. I think that's awesome to hear. Yeah. So would you find, I'm just off the back of that, would you say that like meetups and whatever else is out there sort of help collaborate?
Also the fun part about being here, and which is why I talked about the critical masses. Let's say you're waiting in line somewhere, grabbing food or whatever it is, and you overhear a conversation about something that you've or you've worked and you have a comment or you've struggled, and and sometimes it's hard to escape that. You just want to hear people talk about something else.
Yeah, sure. Right.
That's the flip side of being here.
Yeah. I mean, but if you're passionate enough about it, sure. Yeah. I don't know. I for one, I love this stuff. So, yeah.
No, I'm totally in. Like, I would rather have these conversations, which ultimately lead to something really fun and exciting.
Yeah, sure. So we've talked about like your academic background a little bit, and what it's like in San Francisco, SF.
Yes, that's the right. Don't call it Frisco.
I know that's the tourist. Anyway, so yeah, I'd love to know more about your background in the startup world. I understood from reading your LinkedIn profile that you were in one of the early wave sort of machine learning startups called Neon Labs.
Yeah.
Just picking it up again. So what was it like being part of like a co-founder of an ML startup?
So it was no different from any other startup, I would say. But one of the hardest parts with machine learning back in 2011 and around that time was it wasn't considered real. People hadn't heard about it. It was a very academic concept. And one of the hardest things is my co-founder also is from an academic background. And it was just people thought we were a bunch of nerds trying to make things happen and didn't understand any of the business side of things, which, I would say for a lot of part was true, but I didn't want to admit it. That was the biggest sort of, you would get pigeonholed into, what's your background and all that. So that was the struggle part of it. The other part I would say is machine learning had a flip side. Like it sounded awesome, but it also people were skeptical about how true was machine learning, and people often joke if it was just humans in the background doing doing things versus an actual algorithm doing the work. But on the good side of things, it did open up a lot of doors. People did want to have conversations. But ultimately, I think the advice still stands is machine learning can only open doors. You have to drive business value for your product to be adopted by customers. So you really have to earn your customers' business.
100%. Yeah, I couldn't agree more. I run my own machine learning consultancy, and I'd say it's exactly the same experience. Off the back of that, would you say that being in an ML startup, did you find that you like grew tremendously as a person? Would you say it was
absolutely?
Yeah, major contributor to where you are now?
Absolutely. I think you grow your metal. You have so many roles that you end up playing, that scenarios. It's sort of accelerated learning, I would say. So overall, I think we had the startup for about 4 years. but the amount of experience you gain is probably 8 or 10 years worth of experience, because you're moving at a rapid pace. Scenarios wind up from a customer perspective, be it employees, be it challenges in engineering or science, all of the above, people dynamics. So you grow as a person. If you succeeded at the end, you've certainly grown as a person. And I would say the same. I've become smarter, I've become a better person, all of the above.
Yeah, 100%. I couldn't agree more. If you want to grow in your career, join a startup. It'll be hard, but it's an accelerator for sure. So this with regards to your work at Neon Labs, it mentions you use neuroscience models there. Sorry, just backtrack a little bit. You were trying to identify the best thumbnail images for a video. Is that correct?
Right.
Is that roughly?
Yeah. So
okay, cool.
so essentially, So I'll explain the neuroscience part as well. Essentially, it was based on research where we were trying to understand why people make choice, and in the visual domain. So if you're given a bunch of objects or given a bunch of choices, what compels you to make a choice? So in particular, we were looking at what people find attractive. What is it that you may want to choose given a few options? And we applied that to imaging in general. And the first use case was video, where you have a video is nothing but a sequence of images, and how from that can we pick the best image that is going to likely influence somebody's decision to click. So essentially, more clicks, more ads exposed, more revenue generated.
Awesome. Yeah, cool. Is that like neuroscience models being like, I don't really know much about it, to be honest. So like, is that like behavioral
so
science?
So how do we
type?
proxy? So yeah, exactly, behavioral science.
Yeah.
So how do we? So we designed a tasks and a bunch of tasks and algorithms. So essentially, how can we effectively build without putting people into MRI machines? How can we get a proxy signal? How can we develop a cognitive task and learn from that? So we had a bunch of cognitive tasks that we had designed. We would get the results from that, and we would take that and build a model. So we used MTurk to design a big task. We had a very smart pipeline to extract images from videos, get them labeled, and video has a bunch of space, right? Like you can have cartoons, you can have real images, news, sports, all look very different. It's a better way to actually extract different kind of really populate this hyperspace, so to speak.
Sure.
and label and create this huge model that would embed, given an image, what is what we call as valence, or essentially a choice score that you would attribute to a certain image.
Okay, cool. And were you pairing the behavioral science part with like machine learning models like ConvNets, or I don't know, some classical classifier or something?
I mean, ConvNets weren't. Let's just say they existed, but they're not in the form as they today and easily consumable. So when some of the research had come out, like I wasn't initially convinced to go that direction, I would say, and boy, I was so wrong, huh?
Fair.
But we did do a bunch of deep learning towards the end of the journey there. But initially, it was a bunch of I would say classical machine learning, a combination of a bunch of classical ML algorithms that we used.
Awesome. So it's a behavioral stuff, and was paired with some classical machine learning algorithms, SVMs or something.
I mean, we had experimented by all. Like initial model was an SVM based one.
Yeah.
Then we had a K nearest neighbor based model.
Old KNN.
KNNs,
Yeah.
more like ANNs that were approximate neighbors. So a bunch of variations. To initial, I think it was 2014. Yeah, we're doing a bit of initial
That's cool.
deep, connets. Yeah, but it was very hard back then to get any
There was
of that to
no
work.
real libraries either.
No libraries. Yep.
Yeah.
Yep.
Okay, cool. So moving on from your work in the startup land, so like a large portion of your work, as you mentioned right at the start, was your first love has been around distributed systems. So for those listening in, would you mind explaining what distributed systems are, and then also how you got started in that?
Yeah. Okay. I'll take a very high level approach here. I want to say I would describe anything to be distributed as long as they are individual infrastructure pieces are on different physical devices. So that's what I would say a broad definition of a distributed system would be. So I would say what that does is there are many points of failures in the system. So one of the biggest challenges designing and working in distributed systems are how do you take failure as a first class citizen and as a given rather than design around it. So it is something that you need to consider as part of something that's going to fail, and how do you build systems that are robust to these. So that aspect of being distributed, having a communication overhead. How do you design protocols? How do you design your system? Because your complexity has increased tremendously, but the benefit is that if you can make things distributed, then there's no single point of failure. You can scale, and this was, again, cloud computing was in its infancy when I fell in love, but that was something that was always attractive from.
And around what year are we talking here, if you don't mind me asking again?
This would be I want to say early 2000s. Early 2000s.
Oh wow, impressive.
Early to mid
2000s.
Yeah.
Cool, man. Cool. Right. So distributed systems. I don't know if this naturally leads on, but you've done some work on distributed machine learning systems as well. I know I mentioned a little bit about Berkeley's Ray and stuff like that. Are they distributed machine learning systems that you use on a day-to-day basis? And can you talk a little bit about that?
Yeah, for sure.
Apart from the obvious Sagemaker.
Which I think, I would say
we'll get to
that is what I do use on a daily basis, and naturally curious. I do spend time with systems like Ray and others, and ultimately, the idea here, from my job's perspective, is to how do we make this simple for our customers. So that's basically what I dedicate a lot of time towards, and to be honest, which is why I guess I have to talk about bringing Sagemaker here, which you just mentioned. So essentially, Sagemaker. The story here is we wanted to build an end-to-end machine learning platform to make it easy for data scientists and developers to build models with ease. Right? So there was, if we sort of roll back time and we talked a little bit about that, right? We didn't have libraries, and then let's say back in 2014 and let's say 2016, we had tons of libraries. Explosion of libraries. But the issue was we didn't know which way to go. If you're a customer, if you're a developer, something else was broken. Nothing was containerized. How do you run it on multiple machines? None of that was easy, and you had to spend months of effort to get all of that infrastructure in place before you could actually do machine learning. And so SageMaker there was a solution where we took on the burden and did the heavy lifting on our customers' behalf to build these containers and build the infrastructure pieces wherein you could just bring in your code for TensorFlow or MXNet or PyTorch and then execute that in a distributed cluster. So essentially, spending time on the data science aspects, not the infrastructure plumbing aspects.
So to be clear, SageMaker takes your ML model and the distributed part in the backend is completely taken care for you.
Correct. You can, with a single line, literally a single line change of code, you can specify, hey, I want to run this on 5 instances, or I want to run this on 100 instances. That is the only change that you need to make. And the distribution part is done by SageMaker.
Awesome. Is there any other, so that's one key advantage. Is there any other advantages of SageMaker or high-level descriptions of SageMaker that, so for example, are the majority of the creating models done in, say, a Jupyter notebook, and then from there you take it to be served in the container?
Yeah, so SageMaker has 3 components that are can be used independently, and one is or together, because people have different use cases, and we want it to be modular. So the first piece is the notebook part, wherein you can spin up an instance which runs Jupyter. You can integrate that with GitHub or code commit, and you have a way of actually accessing and collaborating with your other developers in that notebook environment. The second is the train part, where you have a cluster that can spin up and tears down once the end criteria is met as per what you've coded. And the third is, once you've built a model, you can with a transformation function essentially build an endpoint to have a prediction pipeline, either in batch mode or either in a HTTP request response mode.
Right. So when you say that, is that like a REST API? Sorry.
Yeah. So
cool.
You can build a REST API endpoint
RESTful
for your
API.
model. Yeah.
Okay, cool. And that's all pretty seamless, right? I know. I've used it myself for this.
Yeah, it is. I mean, it's pretty seamless, and we've had customers ranging from Intuit to GE Healthcare to tons of startups who've used and reduced spending, let's say, months of efforts to a few weeks to actually get models into production.
Awesome. Yeah. I think having tooling like that is super important. So that's a little bit about SageMaker. So to backtrack a little bit here, you are one of the principal authors, I believe, of SageMaker RL. Is that correct?
So yeah, I was part of the team with SageMaker RL, and more so on the Deepracer side, which is a collaboration between the two of the teams.
Okay, cool. Well, we can talk about that maybe in like 2 minutes, but before we jump into that, would you mind talking about what RL is before reinforcement learning, so that people who might not be aware?
Reinforcement learning is a paradigm of machine learning where you learn through interactions, trial and error, and collection of these, which we call as experience. So as you interact with the environment, you collect the data for the actions that you have taken for the observations that were presented to you. And a reward is associated with every action that you've taken for a given observation. And based on the reward, you try and maximize the total reward that you can get.
Mm-hmm.
In simpler terms, this is very similar to how, let's say, a human teaches their pet. Mm-hmm. The pet is rewarded every time a good behavior is shown, and when bad behavior is shown, you don't give your pet a treat. And so the pet eventually learns to do the good actions which result in a treat. So RL in general is applicable to a lot of use cases where you want to take not just a single decision, but a sequence of decisions.
Sure. Okay. So that's reinforcement learning in a nutshell. How do we go about then taking that explanation and pairing that with SageMaker RL? Where does RL come into SageMaker?
Right. So as I talked about, right, like the complexity of problems that you can solve with reinforcement learning is far greater than. Again, I'm biased towards reinforcement learning here.
Same.
When you compare to compared to other methods, it is large, but with large scope comes large problems, and
Yes,
reinforcement learning,
absolutely.
I would say, typically takes days, sometimes months for your models to converge and really learn, because you have to get lots of experience for you to generalize across different scenarios that you may not have encountered. Like that's the promise of RL, right? Like
Yep.
is
Yep.
you give it a bunch of experience. It's sort of a child learning something. You instruct the child to do a task or not. You give the child feedback, and through this feedback, the child knows what is correct and what's wrong or what's acceptable, and then it can generalize it to a much larger set of decisions that the child has to make when it grows up. So that's similar here in the context of reinforcement learning. And the story was, how do we? RL is not accessible. Like again, fragmented in tons of
Absolutely.
libraries. It took a lot of time for people to get started, and what we wanted to do is, do this undifferentiated heavy lifting to make it easy for people to get started with reinforcement learning. And the core thing is we're looking to democratize, artificial intelligence, and in particular machine learning and reinforcement learning, right? So we built this end-to-end infrastructure where you wanted to use, say, Intel Coach, or you wanted to use Ray or baselines.
Right.
All of those
Cool.
are packaged in. As long as you have the OpenAI Gym interface that your simulation can talk through, that was enough. The RL side of things was already packaged and made available to you.
It's fantastic. So, this is something I'm not sure you can talk about, but I'm gonna shoot, and you can just say yes or no. But can you give examples, I guess, of sort of problems you've had to solve at Amazon, or even maybe broader, with RL, with SageMaker RL particularly? Yeah.
Yeah. So I'll talk a little bit high level within Amazon. I think Amazon Robotics.
Yeah, sure.
Reinforcement learning has a broad set of applications in robotics and industries, or automation within industries, right? So Amazon Robotics is a customer of SageMaker RL. Couple of
Fantastic.
other use cases I would say is GE Healthcare, and the fun part is
Wow.
like how they're using it. They're actually using it for network compression. Network compression in the context of a neural network, because again, as many of us know, not every node in your neural network is utilized. So where you might have memory constraints or computational constraints, you might want to use you might want to not use the entire model, right? Like you want to optimize for that. So
Sure.
GE Healthcare used reinforcement learning
fantastic, man.
to network compression, and that was done on SageMaker RL.
I think one of there's a competition that I know of. I can't remember. I think it's actually held here in Australia for like measuring intelligence, and one of them is is information compression. So that is fantastic that RL has been applied. In such a use case. That's awesome. Okay, so we talked a bit about SageMaker RL and SageMaker RL, which you've been a large part of. By the way, whilst we're talking about that, can you talk about a little bit about the genesis of SageMaker RL, how it came into being?
Sure. Sure.
Yeah, sure.
Yeah. And as I said, the broad story there is fragmentation of libraries, the lack of it took a long time for people to get started, and months of exploration, knowing what tool to use, what version to use. It just took a long time for customers to get started, and we wanted to make that time where they would spend on RL algorithms and not on the infrastructure pieces. So even we went ahead and simplified further, where what we did was the libraries are packaged themselves. So the libraries come with the latest and greatest of algorithms, be it PPO or DDQN, DDPG. All of those algorithms do exist, but then we also connected the bridge with the simulations, right? Like that was again very important for us to do and make that easy. So as long as you had an environment that would override or connect through OpenAI Gym, the rest of the RL pieces existed, and you didn't need to modify anything. So we made that really simple, where you can switch between algorithms really easily. And what your focus was on, what is the reward structure? What does the reward function look like? What are the components, the shaping of the rewards? What is the observation, action space? So you're dealing with the meta parts of the problem and not the tiny core pieces. So we even made it easy with integrations into other simulation pieces within AWS, like AWS Robomaker or Sumerian, and then even MATLAB Simulink, where we actually partnered with them to make the integration easier. So because without simulation and creating those experiences, you're not going to learn. So
100%.
We've made that bridge really easy, and where your focus is on the problem side and not, as I said, on the RL pieces from an infrastructure algorithm side of things. You're really trying to think, how do I solve the problem?
Cool. Yeah. I think this comes back to like what you're talking about before, like when we're moving from like 2013, 2014 to where we are now, where you don't have these libraries, everything is just sort of a mess, really. You're going to figure out the best way of putting it all together. And it sounds like you've taken a massive step forward in that direction. Yeah, cool. So you've talked about wrapping, Intel's Coach, OpenAI Gym, Ray RL Lib. Is there any other? What's the future of SageMaker RL? Is there any addition? Is there any on the horizon? Like, going to be wrapping any future libraries? Yeah.
I think it'll depend on what the customer ask is. So we always listen to our customers. So whichever direction, if there's a new library where we see a lot of customer traction, we're certainly going to invest in making that easier. So I would say like the general direction to expect would be, whatever makes it easier, be it from an algorithm perspective, be it better connectors into other engines that people may want to use for simulation. So I think that's the direction where we would invest based on customer requests.
Absolutely makes sense. Yeah. Okay, so a lot of that work all pretty much leads into the next big thing which you've been involved with, which is Amazon's Deepracer League. So how did you come up with the idea of a real-world machine learning competition? And was SageMaker and RL a big part of that, of the genesis of the next thing?
Yeah, I think we'll tie that story between SageMaker RL and Deepracer. They go very hand in hand. So the initial idea, I've actually been to DIY robocars, and this comes to again the community aspects of San Francisco that we were talking about. I was somebody invited me. Hey, you want to go build some robot cars on a Saturday? I was like, yeah, of course. I mean, who's not gonna? So this was actually Adrian Cockcroft, who's a VP at AWS. He was the one who took me to the meetup back in, I want to say 2000, I forget, 2015, 16, I think. We spent a Saturday on, we saw a bunch of folks building these cars and learning, and I thought to myself, well, this is literally and figuratively a vehicle to teach, deep learning. And we didn't have a lot of people, back then who wanted to use, didn't know how to use, and it was never fun to actually learn. So based on that, I built my own car, got some fun, success, started, documenting and coding this within our organization, and I had other people start building this, and I was like, hey, we should actually turn this into a league. And we then started with Robocar Rally, which was a imitation learning based hackathon, which we did at reInvent 17. It was extremely popular. People, described that as one of the best, workshops they had attended, and everybody, pretty much every team, we had 120 people, pretty much every team who participated got a model working. It was just a lot of fun, and it was a very compelling experience where they, at the end, they came in with no deep learning experience, and they had deep learning experience as they walked through, where they actually knew how to get things work, what are the things that can go wrong. So we were looking at, how do we leverage this, and how do we make this bigger? And I would say reinforcement learning at the same time was something that, as I said, like we were looking to make it easier for customers to access. But again, reinforcement learning is futuristic. How do we educate developers in this exciting field? And it was the synergy was instant. That why don't we actually build Deepracer on top of SageMaker RL as a mechanism to teach people, developers, reinforcement learning in a fun and compelling manner. And that was the origin, and hence, the SageMaker RL team and the Deepracer team, we worked together on building this ground up.
Cool. Yeah, awesome. And it's been, from what I saw at Summit, it looked like it's been a massive success. Speaking of which has been the biggest success that you've seen emerge out of Deepracer? Some success stories. I mean, we can talk numbers, and then I can give you some of what I personally consider the best. So, we've had about 5,000 plus people across the world test their models in real life. We've had over 20,000 model submissions. Man. Again, all over the world, across different competitions. So all that, it's great to see people participate in huge numbers and participate. But to me personally, like when I look at this, is what people have learned is the interest they've shown in reinforcement learning and what they've been able to do and learn. I think that to me personally is the highlight. And we see this at competitions across the world where I would say a vast majority of the winners had no reinforcement learning background. Really?
When they came in. They come, they attend the workshop, they're looking at online materials that we have, reading through it, and then they're coding things up, and then they are shattering world records in the leagues. So that to me, is the part that I would say is the most exciting, to see people with no background actually become experts in reinforcement learning and being able to build these models.
Yeah, it's really clever. I think pairing a competition with a usable tool, Sagemaker RL, is
Right.
it's
And
the
to
right
be
way to do
honest,
it. Yeah.
like there's an element of competition you see every time, but there's also an element of collaboration, because the
Has to be.
intent that people come with is learning, and I'm happy that we've facilitated a learning environment that's made it easy for people, and RL more accessible.
Yeah, cool. So it's it was Deepracer was run here in Sydney, and it's toured all around the world. Is there plans to run it again next year, 2020?
Of course,
There is?
we it will. Yep, we'll continue. The league is still in existence. We have for this year's league, the final competition will be in Las Vegas, the first week of December.
Awesome. And how does that work? Just because this is something I'm not aware of, are like people that win in, say, Sydney and then wherever, like London, SF.
Yeah, so we had over 21 physical summits. So we'll have all the winners from those physical summits, and then we ran a bunch of virtual leagues. So all the winners from virtual leagues will come in,
and they've flown in to Las Vegas. Wow.
Yeah, they all the winners got a full expense trip.
There you go. To anyone listening,
in.
Some motivation for next year.
Yeah, so they've come in at reInvent. They're all going to compete and produce amazing models. I can't wait to see the excitement.
That'd be fantastic. Cool. Well, one more final thing I'd like to pick your brains about, Sunil, and then I guess we're out of time. So again, you're the principal deep learning scientist at the Amazon ML Lab. Can you tell us a little bit more, and again, at a high level, I guess, about what the ML Lab does, and any sort of exciting projects that you can talk about?
Sure.
That are maybe in the works or have been done in the past? Yeah.
Yeah, certainly. So the machine learning lab came into existence, solutions lab came into existence where we saw there was a gap for customers to actually adopt machine learning, wherein the customers had a lot of experience in their own domain, but didn't necessarily have the machine learning expertise. So we wanted to bring the level of, we at Amazon in general have had 20 years of experience building machine learning applications. So how do we bring our expertise in machine learning and pair it with our customers and expedite solving the problem? And our goal here is to, help solve the problem, but also empower our customers to, we actually teach them machine learning, we empower them with the tools so that they become self-sustainable. To use a phrase, we're teaching them to fish.
Yep.
So we're teaching them to ML.
Fantastic analogy, man.
That is what we try to do at the machine learning lab. And one of the projects that I can talk about is in the healthcare space, where we collaborated with Cerner, where I worked with Cerner to produce or build models. I don't have a healthcare background per se, but I picked up some working with them and building building chronic disease prediction. So essentially, given a timeline of patient data, when is somebody likely to have congestive heart failure? So that as an example. That's something that we worked on.
That's fantastic. Cool. And then I guess to wrap it up, so there'll be many people listening to this, thinking about how they can get involved in AWS's ML lab. So how do you go about applying? Do you is there a link online on a web page somewhere? Do you just do the general Amazon?
we have. Yeah, so
And also, what experience are you looking for? That's, I think, also.
Yeah, so for sure, like, I mean, I'd start with the experience. We're looking at all across the spectrum, from people who have a good machine learning background, but maybe straight out of college, to people who've been doing this for a long time. So we have variety of positions actually all over the world that is open in our group. Jobs.amazon.com is where you should go check these out. You can find me on LinkedIn or Twitter. Send me a message. More than happy to review and guide you in the right direction. And we work on a variety of problems, from sports, like as an example, our team's been working with the NFL, the Major League Baseball, to healthcare healthcare companies that I mentioned, to in the automotive space with Toyota Research. So wide variety of customers that we've worked over the years, and we still work with. So it's a fun place where real problem solvers are going to have a lot of fun and grow.
Yeah, and yeah, I think like applied ML is where it's going to be in the 2020s, no doubt. Like actually taking it in.
Certainly agree.
Yeah. Well, Sunil, it's been an absolute pleasure, mate. Yeah, we'd love to do this again, maybe in a year's time. But thank you so much, mate. And
thanks, Paul. Thanks. This has been a great chat, and thanks for all the awesome questions.
Cheers, mate. Thank you.
Cheers.
Hi everyone, I hope you enjoyed that episode. If you liked it, please feel free to like, click or subscribe, as that would really help us out and help the channel grow. Cheers and see you next time.